Oh, hey! Didn't see you there. I'm Rachel Windsor.
And I'm Nicole Piscopo.
And I'm Takumi Otsuka.
And this is our group project for ECE 2001W.
Let's take a look, shall we? Here's our overall circuit. This top portion up here is our microphone configuration. Down here we have our music configuration. These both feed together, sum right about here, and go into our final piece of our summing circuit, which then outputs to our laser. Right here we have our microphone, which is biased with about 4.5 volts, and we have an equivalent resistance of 10.1 kiloohms and a 22 microfarad capacitor. This feeds into the potentiometer, which we use as voltage control, and that then feeds into an op-amp, which has a gain of 51. From there, this will go into our summing circuit. Next, we have our music component. So our music comes in through these cables here into this potentiometer, which again controls volume. We then have an equivalent capacitance from these two capacitors of 11 microfarads. And we then have an input of 15.1 kiloohms into our final op-amp, which then has a feedback resistance of 51, which results in about 3.4 gain. And this again comes into our summing circuit.
On the right-hand side of our transmitter circuit, we have a final op-amp, which sums the two signals together and actually has a gain less than 1 in order to prevent any clipping. This final op-amp is biased with 4.5 volts via this voltage divider. In addition, it's connected to our final laser, which is further biased with approximately 9 volts with an inductor and a capacitor. The inductor and capacitor prevent any backflow into the circuit of AC or DC current.
Okay, so over here on the receiving end, we have a solar panel which receives the signal from the transmitting laser. The solar panel signal goes through this 10 microfarad capacitor, which filters out any DC current and also like surrounding lights. It then comes to an op-amp feedback loop with a 10 kiloohm resistor here and then a feedback resistor with a value of 510 kiloohms, ultimately giving us a gain of 51. The 9-volt battery then comes into a voltage divider with two 100 kiloohm resistors in parallel. This biases the op-amp to 4.5 volts. There's then a 1.1 megaohm resistor which inhibits current flow through the op-amp. Ultimately, this all comes to the speaker through this node.
Alright, so now for a practical demonstration. We have an iPhone hooked up to the auxiliary cable, and we also have just an iPod Touch to play through the microphone. For the sake of simplicity, we haven't separated our circuits by that much. If we had to, we could separate it by, theoretically, just as far as the laser shines. But here we go. So first, just the iPhone. We have some M&M. As you can see, the signal passing through the laser is clearly audible on the other side. We can also use these potentiometers as volume controls, so we can turn it all the way down and no sound comes through, or all the way up. And there's an audible volume difference. Now, the other side, potentiometer turned all the way up. This is Beyonce, and as you can see, it's clearly audible. And as before, we can use the potentiometer like a volume control, by turning it all the way down. No signal comes through. Alright, so what you're hearing right now is just what's coming through the microphone. Due to my shaky hand, it sounds a little iffy, but if I can get it steady, we get a pretty clear signal. And if Rachel plays a song, through the iPhone, we're currently hearing a mixed signal of both Beyonce and the Veronicas. So this is our project. Hope you enjoyed it. It's pretty cool.